settle into the sleepy mind channel. Today we will explore one of the oldest and most remarkable living worlds on Earth. Coral reefs cover less than 1% of the ocean floor, yet they support about a quarter of all marine life. This is one of the great wonders of the natural world. In clear tropical seas, what may appear at first to be colorful underwater rock is in fact something alive, growing, feeding, competing, and building over immense stretches of time. Coral reefs are often called the rainforests of the sea, though in some ways they are even stranger. A rainforest rises towards sunlight through trunks and leaves. A coral reef rises slowly from tiny animals building stone beneath the water, layer by layer, century after century. Corals are not plants, and they are not simply rock formations shaped by the sea. Corals are animals. This surprises many people because reefs can look motionless and almost mineral in their stillness. Yet every living coral colony is made of countless small animals called polyps. Each polyp has a soft body and a ring of tentacles used for feeding, and each one lives within a tiny limestone cup it creates for protection. A reef that may seem solid and ancient is, in truth, a vast community of these small living creatures, each carrying out the quiet work of life. A single coral polyp is delicate and simple in form, almost flower-like in appearance, though it belongs to a much older and stranger branch of life. Coral polyps are close relatives of jellyfish and sea anemones. This connection becomes easier to imagine when one sees the tentacles of a coral extended in moving water, drifting gently as they capture tiny food particles from ocean currents. The hard reef is built by soft-bodied animals whose ancestors have existed for hundreds of millions of years. What makes this even more remarkable is scale. One coral colony may contain thousands of polyps living side by side, each adding a thin layer of limestone skeleton beneath itself. Over long spans of time, these skeletons accumulate. Colonies grow outward and upward. New generations build upon old foundations. Small living creatures create reef forms visible from space. Great reefs begin with countless tiny acts, repeated almost beyond measure. Growth happens slowly. Some reefs expand less than an inch in a year. In human terms, this seems almost still. Yet over centuries, slow growth becomes architecture. Over thousands of years, it becomes landscape. Massive reef systems, stretching for hundreds of miles, owe their existence to this patient accumulation. There is calm in that thought, that some of the largest living reef forms on Earth are built through almost imperceptible growth. Some coral colonies alive today began long before modern nations existed. Some have endured through changing seas, shifting climates, storms, and ages of rising water. They are living reef forms, carrying deep time within them. To drift over a reef is to drift over layered history built by creatures no larger than fingertips. Yet a coral reef is not merely coral, it is a city of life shaped by coral builders. Fish shelter in branching colonies, crabs move through crevices, shrimp clean larger animals at hidden stations, eels rest in shadowed cracks, turtles feed over coral gardens, predators patrol beyond the reef edge. Countless forms of life depend upon the architecture corals create. The reef is animal-built habitat supporting worlds within worlds. This richness is one reason coral reefs hold such fascination. They are places of beauty, certainly, but also places of immense biological complexity. Competition for space can be fierce. Tiny territories matter. Corals may grow against neighboring colonies in silent rivalry. Fish establish feeding grounds. Creatures hide, hunt, clean, spawn, and survive among reef forms built over centuries. Beneath the calm movement of tropical water, reef life is active beyond easy measure. There is also a paradox at the heart of coral reefs. They thrive in waters often poor in nutrients, seas that may seem too clear and sparse to support such abundance. Yet reefs flourish there through remarkable efficiency, recycling, and partnership. This hidden cooperation lies at the foundation of reef life, though it is not visible at first glance. The secret of coral abundance begins in one of the most important partnerships in nature. Within the tissues of most reef-building corals live tiny algae. These tiny organisms use sunlight to produce energy through photosynthesis, and much of that energy is shared with the coral animals that shelter them. In return, the coral provides nutrients and protection. It is a partnership so intimate that reef building on a grand scale depends upon it. Much of the color seen in living coral comes from this alliance. Much of the reef's growth depends upon it. The brilliance of coral reefs begins with cooperation at tiny scale. This partnership helps explain why reefs grow in warm, shallow, sunlit seas. Sunlight fuels the algae. The algae help feed the corals. The corals build reefs that shelter entire ecosystems. Vast living worlds rise from this quiet relationship, repeated in millions upon millions of tiny animals. Few partnerships in nature shape the world so profoundly. And there is wonder in imagining it all from below the surface. Sunlight filtering through warm blue water, coral branches reaching upward, fish flashing among living towers, polyps opening with evening currents, slow growth continuing through night as it has for ages. A reef can seem still from afar, yet at every scale life is unfolding. To begin understanding coral reefs is to begin with this simple revelation. They are living architecture built by animals. They are ancient, patient, and remarkably complex. They seem almost impossible in their richness, and yet they exist because countless small lives cooperate, grow, and build. That hidden partnership between coral and algae, between animal and sunlight, lies at the center of the reef's existence. From that quiet alliance, the whole reef world rises, and it is there the story moves next. The living partnership at the heart of a coral reef is one of the most remarkable relationships in nature. Hidden inside the tissues of most reef-building corals are tiny algae, so small they cannot be seen individually, yet so important that entire reef ecosystems depend upon them. These tiny organisms live within coral polyps in a close partnership shaped over immense spans of time. It is not simply coexistence, but cooperation so complete that coral reefs as we know them would scarcely exist without it. Some of the greatest living reef forms on Earth rise from this quiet alliance between sunlight, algae, and animal life. The algae use sunlight to produce energy through photosynthesis, transforming light into nourishment. Much of this energy is passed to the coral host. In this way, coral animals receive a major share of their food, not only by capturing drifting particles from the sea, but through the sunlight harvested by their tiny partners. It is a beautiful arrangement. The coral provides shelter and nutrients. The algae provide food. Each helps sustain the other. This exchange happens continuously, silently, in every sunlit reef where healthy coral grows. This partnership helps explain how reefs flourish in clear tropical waters that can seem surprisingly poor in nutrients. At first this appears puzzling, In many ecosystems, great abundance is associated with rich soils or nutrient-filled waters. Coral reefs often thrive where the sea appears almost sparse. Their abundance comes not from excess resources, but from remarkable recycling and efficiency. Energy captured through sunlight is used again and again through tightly linked living relationships. Reefs do not simply survive in these waters, they turn apparent scarcity into remarkable abundance. The algae do more than feed the corals. They also help support the growth of the limestone skeleton that reefs are built from. Through processes linked to this partnership, corals are able to deposit calcium carbonate, the mineral substance forming their hard reef form. Layer by layer, this builds the architecture of the reef. Tiny living polyps, sustained by tiny algae, slowly raise reef forms large enough to shape coastlines. It is difficult to imagine a more profound result arising from such small beginnings. The vivid colors of healthy coral reefs also owe much to this partnership. Many corals draw part of their rich browns, golds, greens, and softer hues from pigments linked to the algae within them. A thriving reef glows with color, partly because of the countless living partnerships woven through its surface. Even beauty on the reef often traces back to cooperation. Yet this alliance is delicate as well as powerful. Corals thrive within fairly narrow temperature ranges, often in waters between about 70 and 85 degrees Fahrenheit. Within those conditions, the partnership flourishes. Sunlight is abundant, growth continues, reef life expands. But when water becomes too warm for too long, the relationship can come under stress. Corals may expel their algae, and the living colors of the reef can fade. This process is known as coral bleaching. When the algae leave, the coral's white limestone skeleton shows through the transparent tissue, giving bleached corals their pale appearance. Though often spoken of as death, bleaching is first a stress response. Corals may survive if conditions improve and the partnership is restored. Yet prolonged stress can weaken or kill coral colonies. The phenomenon reveals how deeply reef life depends upon this tiny alliance. There is something poignant in that. The grandeur of reefs, their beauty, diversity, and ancient persistence rests partly upon a partnership invisible to casual view and sensitive to changing conditions. Great reef forms can depend upon fragile balances. Coral reefs embody this truth in a particularly striking way. And still, even under this delicacy, there is resilience. Coral colonies have persisted through shifting seas and natural changes for thousands of years. Their partnerships have endured storms, warming periods, cooling periods, and rising waters across long stretches of Earth's history. Reefs are not fragile in the simple sense of weakness. They are ancient systems shaped by both sensitivity and endurance. Their growth remains remarkably slow. A reef may add only tiny increments each year. Some branching corals grow more quickly, while massive corals may expand with patient slowness. Yet over generations, that slow building creates immense reef forms. This invites a different sense of time. Human projects often seek speed. Coral reefs are built through patience. Their architecture is the work of centuries quietly layered. Some coral colonies alive now may have begun growing before many familiar human landmarks existed. Their stone reef forms hold histories longer than memory. To move above a reef is to drift over accumulated time, each ridge and branch shaped by countless small acts of growth. As reefs expand, they begin shaping larger forms. Over time, they can become barrier reefs running parallel to coasts. They can fringe shorelines. They can form great ring-shaped atolls where old volcanic islands once stood. These immense formations begin in the same slow process, polyps living with algae, building upward through generations. The grandest reef landscapes rise from the same partnership explored here. There is calm wonder in seeing how much begins with relationships hidden from sight. Sunlight enters shallow water. Tiny algae gather energy. Corals share in that energy. Limestone skeletons grow. Reefs rise. Fish gather. Ecosystems flourish. Coastlines are protected. Vast marine worlds emerge from a quiet exchange repeated countless times. This ancient partnership between coral animals and sunlight through living algae lies at the foundation of reef existence. Yet from this small-scale cooperation come reef forms so immense they can stretch for more than 1,000 miles. To understand how reefs become such vast living landscapes, the story now turns toward those great reef builders and the monumental reef forms they create. From the quiet partnership between coral polyps and sunlight gathered through living algae rises one of the greatest constructions in the natural world. Coral reefs are not simply clusters of colonies scattered across shallow seas. Over immense spans of time, they become vast living landscapes, shaping coastlines, tracing ancient volcanic rims, and stretching across oceans in reef forms so large they can be seen from space. It is remarkable to consider that some of the grandest biological formations on Earth are built by tiny animals adding thin layers of limestone year after year. Yet this patient construction has produced reef systems of remarkable scale and age. Some coral colonies are hundreds of years old. Some may be far older. Certain reef systems began forming thousands of years ago as seas rose after the last ice age, while the ancestors of reef-building corals themselves reach back far deeper into Earth's history. In this sense, coral reefs are both ancient and ongoing. They are relics of deep time still actively growing. Unlike ruins of vanished worlds, reefs are living reef forms whose oldest parts may be ancient, while their surfaces continue expanding through the work of present life. This long continuity gives reefs a quiet grandeur. A forest may seem old after centuries. A coral reef may carry layers built through millennia. Some massive corals grow so slowly that their forms preserve the rhythm of time in almost geological patience. To drift above one can feel less like visiting a habitat and more like entering a living archive. No reef better captures this sense of scale than the Great Barrier Reef. Stretching for more than 1,400 miles along the coast of Australia, it is the largest coral reef system in the world. Its size is difficult to imagine. It is not one single continuous wall of coral, but a vast interconnected system of thousands of reefs, islands, channels, and lagoons. Seen from above, it forms immense patterns across the sea. Seen from space, its scale becomes visible beyond ordinary human perspective. It reminds us that coral reefs are not merely delicate gardens, but planetary features. Yet even the Great Barrier Reef began through the same slow accumulation already explored. Countless coral colonies building upward through generations, layer upon layer, life making stone, stone becoming habitat, habitat expanding into landscape, vastness born from repetition. This is one of nature's great themes. Reefs form only under certain conditions. Most reef-building corals thrive in warm, shallow, sunlit waters, where light can reach the algae living inside their tissues. Temperature matters, clarity matters, depth matters. The reef is shaped by a narrow environmental window, which helps explain why tropical seas hold so many great coral systems. In such waters, sunlight pours downward through blue clarity, feeding the hidden partnership at the center of reef growth. Warm, shallow seas also allow another quiet miracle. As coral skeletons accumulate over long spans, they begin building reef forms that alter water movement itself. Reefs influence waves, currents, and sediment. They do not merely inhabit environments, they help shape them. This is one reason reefs can become so important to coastlines and marine life alike. There are several great forms reefs take. Fringing reefs grow directly along shorelines, often forming the first coral margins beside tropical islands and continents. Barrier reefs form farther offshore, running roughly parallel to land, with lagoons between reef and coast. These can reach enormous scale. Then there are atolls, among the most elegant reef forms in nature. An atoll often begins around a volcanic island. Corals grow in shallow water around the island's rim. Over immense spans of time, the volcanic island may slowly sink, while coral continues growing upward toward sunlight. Eventually, the central island may disappear below the sea, leaving a ring of reef surrounding a lagoon. The atoll traces the ghost outline of a vanished volcano. There is poetry in that, though grounded in geology. A mountain sinks. A reef remembers its shape. This ability of reefs to keep growing upward while landscapes change is part of their endurance. Even rising sea levels, within limits, can sometimes be matched by upward reef growth. Corals have long persisted through changing oceans, partly because they are not passive reef forms. They grow with the world around them. And growth takes many forms. Some corals spread in massive rounded forms, layer upon layer like living stone domes. Some branch outward in delicate antler-like patterns. Some form ridges or plates catching sunlight. Together, these forms create architecture of remarkable complexity. Each shape influences which fish shelter there, how currents move, where larvae settle. The physical form of coral shapes the community living around it. There is something remarkable in how much life depends on these ancient builders. Reefs provide shelter for fish, feeding grounds for turtles, hunting territory for predators, nurseries for young marine life. A reef is reef form, refuge, and living city all at once. Without coral architecture, much of this abundance would not exist. And still, despite their vastness, reefs grow with slowness that invites humility. An inch in a year may seem almost nothing, yet over centuries it becomes reef crest. Over millennia, barrier systems. Over ages, some of the grandest biological formations on Earth. Nature often builds greatest through patience. The Great Barrier Reef is only one expression of this planetary architecture. Across tropical seas, reefs rise along coasts, around islands, over old volcanic foundations, each shaped by sunlight, temperature, currents, and time. Their forms differ, yet all begin in the same small living builders explored from the beginning. There is calm wonder in tracing this path from tiny polyps to reefs visible from space, from tiny partnership to ancient living continents beneath the sea. Few natural stories move so seamlessly from the smallest scale to the immense. Yet even these ancient builders live within delicate conditions. Warmth that nourishes can also become stress. The same sunlight-sustaining reef growth can illuminate bleaching when the hidden partnership falters. To understand coral reefs fully, it is time to turn toward that fragile threshold where living color can fade and where the white skeleton beneath the reef begins to show. For all their age and grandeur, coral reefs depend upon balances that can be delicate. Warm, shallow seas, abundant sunlight, and the quiet partnership between coral animals and tiny algae make reef growth possible, yet these same conditions exist within limits. When those limits hold, reefs flourish in color and abundance. When they are pushed too far, stress begins to appear in one of the most striking processes in the ocean, coral bleaching. To understand bleaching is not only to understand a modern concern, but to understand more deeply how living coral exists at all. Most reef-building corals thrive in waters within a relatively narrow temperature range. This does not mean reefs are fragile in a simple sense. They have endured storms, changing seas, and natural variation for ages. But like many complex systems, they depend upon conditions staying within certain bounds. When water grows too warm for extended periods, the coral and algae partnership can become stressed. The coral may expel the algae living inside its tissues. What follows is one of the most dramatic transformations in nature. Healthy coral often carries rich color through the living tissue and the pigments associated with its tiny partners. When those algae leave, much of that color disappears. The coral turns pale or white as its limestone skeleton shows through beneath thin, translucent tissue. This is bleaching. It can make living reefs appear ghostly, as if color itself has drained from the seascape. Yet bleaching does not immediately mean death. This is important and often misunderstood. A bleached coral may still be alive. If stressful conditions ease, algae may return and the partnership can be restored. Corals can recover. Reefs have done so many times. Bleaching is a sign of strain, not always an ending. There is resilience here as well as vulnerability. Still, prolonged stress can be severe. Without their tiny partners, corals lose a major source of nourishment. Growth slows. Survival becomes harder. If stressful conditions continue too long, coral colonies may die. This is why bleaching matters so deeply. It reveals how much reef life depends on relationships invisible to casual view. There is something profound in that hidden dependence. Vast reef systems, visible from space, rely partly on tiny algae living within animal tissues. The grandeur of the reef rests upon intimacy. Great reef forms depend upon tiny partnerships. This pattern appears again and again in nature. Bleaching also reveals something about coral skeletons themselves. Beneath living tissue lies the limestone reef form corals build from calcium carbonate. This mineral skeleton is the architecture of the reef. Each generation of polyps lays new skeletal material over older foundations. Over time, layers accumulate into ridges, towers, buttresses, and reef walls. Even when living color fades, the white skeleton reveals the physical reef form quietly built over centuries. Calcium carbonate may sound like a simple mineral substance, yet it forms one of the great biological constructions on Earth. Tiny polyps draw dissolved materials from seawater and turn them into stone. Through repetition, this becomes reef. Through ages, it shapes coastlines, it is difficult not to feel wonder at such patient engineering. Layer after layer of coral skeleton forms the massive reef forms, supporting whole ecosystems. Some living corals grow atop ancient dead coral reef forms laid down by earlier generations. In this way, reefs carry their own history within their reef form. Living surface above, older foundations below, all built through continuity. A reef is both present life and accumulated past. And reefs do not merely sit in the sea as passive formations. Their reef forms shape water movement. They break waves. They create lagoons. They offer crevices for shelter and feeding. Their architecture generates habitat. Coral skeletons may seem inert compared with living fish, yet without these hard reef forms, much reef life could not exist. There is beauty in the forms corals make. Some resemble branching antlers. Some rise in domes like living boulders. Some spread in layered plates catching sunlight. Brain coral folds in labyrinth patterns. Staghorn corals branch like underwater forests. Each form reflects growth strategies shaped by currents, light, and survival. And all this living architecture remains dynamic. Storms may break coral, yet fragments can sometimes reattach and grow into new colonies. Broken pieces may become beginnings. Damage may create openings where fresh growth takes hold. Reefs are not static monuments. They change, recover, compete, rebuild. There is calm perspective in remembering how long reefs have persisted through natural change, through warming and cooling seas, through rising waters after ancient ice ages, through storms and shifting coastlines. Coral reefs carry histories of endurance not always visible when we look only at present stress. Their story includes resilience as well as delicacy. Still, bleaching teaches humility. It reminds us that even ancient systems can depend on balances easily overlooked. Warmth can nurture and also strain. Sunlight can sustain and expose. The same reef glowing with life can reveal, in whitening skeleton, how finely tuned its living relationships are. And from those skeletons, layer by layer, come the great reef forms stretching beside continents or circling old volcanic islands. To understand those monumental reef forms more fully, the story now turns from bleaching and living stone toward the ways coral builds the larger architectures of fringing reefs, barrier reefs, and the ring-shaped atolls of the tropical sea. From the slow growth of coral skeletons arise some of the most elegant reef forms in the natural world. Reefs do not form in only one shape. Over long spans of time, they develop into distinct patterns shaped by coastlines, volcanic islands, sea levels, and the patient upward growth of coral toward sunlight. These forms, fringing reefs, barrier reefs, and atolls, reveal that coral is not merely building habitat for marine life, but shaping landscapes across the sea. What begins as colonies of tiny polyps can become reef forms large enough to influence shorelines and trace the memory of vanished islands. The simplest and often earliest reef form is the fringing reef. These reefs grow directly along coastlines, often bordering tropical islands or continental shores. In shallow, clear water, coral colonies spread outward from land, creating living margins where reef and shoreline meet. Seen from above, fringing reefs may appear as luminous bands of turquoise and deeper blue, tracing islands like living borders. For countless marine species, these reef edges become shelter, feeding grounds, and nursery habitat. For people living beside them, they may seem as much a part of the coast as beaches or mangroves. Fringing reefs often reveal the intimate relationship between land and sea. Rivers, sediments, currents, and shorelines can all influence their growth. Where conditions remain favorable, coral slowly extends outward, adding complexity through branching colonies, coral heads, and reef flats shaped by waves. What appears at first glance as a simple shoreline reef is often a layered living landscape built through centuries of quiet accumulation. Farther offshore, another great reef form emerges, the barrier reef. Unlike fringing reefs, barrier reefs lie separated from land by lagoons or deeper channels. They may run parallel to coastlines for remarkable distances. The Great Barrier Reef is the grandest example, but barrier reefs occur elsewhere across tropical seas. Their scale can be immense. Long reef walls break incoming waves, while lagoons form calmer waters between reef and shore. This arrangement creates entire marine worlds shaped by the reef itself. There is something majestic in the idea of a reef acting as both living habitat and geological presence. Barrier reefs do more than support marine life. They influence coastlines, soften wave energy, and help protect land from storms and erosion. They are living breakwaters, formed not of poured stone, but of patient biological construction. Some coastlines owe much of their protection to reefs that have quietly absorbed wave force for ages. Then there are atolls, the most beautiful expression of coral growth shaped by deep time. At first glance, an atoll may seem almost too symmetrical to be natural, a ring of coral islands and reefs surrounding a tranquil lagoon. Yet its story is one of slow transformation. An atoll often begins with a volcanic island rising from the sea. Coral grows in shallow water around its shores, forming a fringing reef. Over immense spans of time, the volcanic island may slowly sink or erode, while the coral continues growing upward towards sunlight. If this process continues, the island may disappear beneath the sea, while the coral ring remains. What is left is an atoll, a living circle, marking the outline of a vanished volcano. There is deep wonder in this process. A mountain sinks. Coral remembers its shape. A lost island leaves a living ring across the ocean. Few natural stories feel so graceful. Atolls also show how reefs respond to change. Rather than remaining fixed while the world shifts around them, reefs can grow with changing sea levels, rising upward as waters rise. This capacity has helped reefs persist through long environmental change. Coral architecture is not rigid. It is responsive through growth, and each reef form shapes life differently. Fringing reefs close to shore often mingle with seagrass and mangrove habitats. Barrier reefs create lagoons supporting their own rich communities. Atolls can hold remarkably distinct marine ecosystems enclosed by their ring reef forms. Form shapes ecology, architecture shapes abundance. Reefs also grow upward and outward through continual layering. Living coral covers outer surfaces where light reaches. Beneath may lie centuries of older coral skeletons compacted into reef foundations. What looks like a single reef may be a layered history of growth, storms, recovery, and new construction. The reef is both present and accumulated past. There is something almost city-like in this architecture. Reef ridges rise like walls. Lagoons lie like protected harbors. Coral towers and crevices form neighborhoods for fish, shrimp, eels, and countless other creatures. Though built without intention, Reef forms create living spaces of remarkable complexity. And still all this depends upon slow growth, often less than an inch a year. The patience of coral remains one of the great quiet themes beneath reef grandeur. Fringing reefs tracing islands, barrier reefs stretching for vast distances, atolls circling lagoons, all arise through almost imperceptible building, repeated through time. Reefs can also create natural lagoons where waters remain calmer and often teem with young marine life. These sheltered places can serve as nurseries where smaller fish grow before moving toward outer reef slopes. Once again, reef architecture shapes not only form, but the life cycle of entire communities. As these great reef forms grow, they also begin serving another role. They become protection. Reefs absorb wave energy. They soften storms. They help shield coastlines from erosion. The same coral architecture supporting marine abundance also guards land. This protective role links reef life to worlds above the water as well as below. There is quiet beauty in that. Tiny coral polyps, building limestone grain by grain, help create reef forms, protecting tropical shores from powerful seas. What seems delicate can hold immense strength, and within those reef forms, life gathers in remarkable abundance. Fish shelter among coral branches, grazers shape reef surfaces, predators patrol reef edges. Competition for territory unfolds in spaces built by living stone. To understand reefs fully, it is time now to enter those crowded living cities and explore the reef as one of the most diverse communities in the ocean. Once coral has built its great reef forms of walls, ridges, lagoons, and branching cities of stone, those reef forms begin supporting one of the richest communities in the ocean. Coral reefs cover only a tiny fraction of the seafloor, yet they support about a quarter of all marine life. This fact alone remains remarkable. Such abundance gathered in so little space suggests something unusual is happening there. A reef is not simply habitat. It is a densely layered living city where nearly every surface, crevice, current, and shadow may hold life. To drift above a reef is to see movement almost everywhere. Fish pass in schools over coral heads. Smaller species weave among branching colonies. Crabs move over limestone ridges. Shrimp shelter in hidden chambers. Sea stars cling in quieter places. Eels watch from crevices where daylight reaches only dimly. Life is not spread thinly here. It is gathered in intricate concentration. Much of this richness comes from reef form. Coral creates surfaces, overhangs, caves, ledges, and narrow openings where different creatures find shelter according to size, behavior, and need. A branching coral may shelter tiny fish escaping predators. A deep crevice may hide a moray eel through daylight hours. A coral ledge may become feeding ground for grazing species. The reef contains many habitats folded together in remarkably small space. This layered architecture is one reason biodiversity flourishes so intensely. There is often competition in such crowded abundance. Space on a reef is precious. Corals compete with sponges and algae for territory. Some corals can extend stinging tentacles against nearby rivals, gaining ground through slow, silent conflict. Even creatures that appear still may be engaged in constant struggle for space and survival. Beneath the reef's calm beauty, there is continual negotiation. Fish communities add another layer of complexity. Thousands of species may inhabit reef systems, many with brilliant colors used for camouflage, recognition, courtship, or warning. Some blend perfectly into coral textures, others flash in vivid blues, yellows, and silver. In clear tropical water, a reef can appear almost painted with moving color. Parrotfish are among the great architects of reef life. They graze algae from coral surfaces with beak-like mouths, helping prevent algae from overwhelming the reef. In feeding, some grind bits of coral skeleton into fine particles that pass through them as sand. Much white tropical beach sand comes, remarkably, through this process. Even beaches can owe something to reef fish. Cleaner shrimp and cleaner rasa create another remarkable layer of reef society. At cleaning stations, larger fish approach and hold still, while parasites are removed by much smaller creatures. Predator and prey relationships may pause in these moments of mutual benefit. Such scenes reveal a social intricacy in reef life easy to overlook. There are predators too. Reef sharks patrol outer slopes as top hunters within these ecosystems. Their presence helps maintain balance in subtle ways. Predators shape the behavior of other species, influencing where fish feed and move. A healthy reef often depends upon such relationships as much as upon coral growth itself. Sea turtles graze along reefs. Giant clams rest embedded among coral, filtering water and sometimes living more than a century. Moray eels emerge at dusk to hunt through crevices they occupied through daylight. Every part of the reef has its inhabitants. Some of the most famous reef relationships involve clownfish living among sea anemones. Protected by mucus that allows them to avoid the anemone's sting, they shelter among tentacles while offering cleaning and other benefits in return. Once again, the reef reveals how often cooperation sits beside competition. There is also the constant shaping force of grazers. Herbivorous fish help keep algae in check. Without them, algae may spread across coral surfaces and alter the balance of the reef. Even seemingly simple feeding behavior may support entire ecosystems. On reefs, ordinary acts often carry large consequences. And there is rhythm to reef life. Day belongs to some species. Night transforms the community. Creatures hidden in daylight emerge. Hunters begin moving. Coral polyps may extend feeding tentacles after dark. A reef changes character with the passing of light, like a city shifting from day into evening. There is wonder too in how much of reef life depends upon tiny spaces. A small crevice may hold species found nowhere else. A coral branch no larger than a hand may shelter an entire small community. Great abundance is often built at miniature scale. Yet despite all this beauty and variety, reefs are not peaceful gardens in the simple sense. They are dynamic, competitive ecosystems where growth, defense, feeding, and survival are always unfolding. Their richness comes partly from this restless interaction. There is calm in recognizing how much life can gather through reef form and relationship. Tiny coral animals build the city. Countless creatures inhabit it. Grazers shape it. Predators balance it. Cleaners maintain hidden health. The reef becomes not merely a place where species live, but a living network. And among the colors, rivalries, and crowded abundance, the reef reveals even stranger wonders. Some corals glow beneath ultraviolet light. Some organisms produce their own light. Some reefs release clouds of life during synchronized spawning tied to moon cycles. From the crowded reef city, the story now moves toward these luminous and remarkable hidden marvels of reef life. Beyond the crowded city of reef life lies a world even stranger, where color, light, reproduction, and hidden rhythms make coral ecosystems feel almost otherworldly. Coral reefs are often admired for vivid beauty, yet much of that beauty has purpose. Colors may help creatures hide, signal to one another, warn rivals, or blend into shifting patterns of light. What appears decorative is often part of survival. A reef is not colorful by accident. Its brilliance belongs to the life unfolding there. Some reef fish shimmer in electric blues or bright yellows that seem impossible beneath water. Others carry stripes, spots, or shifting patterns that break up their outlines against coral textures. Camouflage on reefs can be dazzling rather than dull. A fish may vanish among branching coral through colors so vivid they seem conspicuous, yet within the reef they become concealment. Beauty and survival often meet in the same form. Corals themselves contribute much to this underwater radiance. Pigments in living coral tissues and their tiny partners help create warm golds, reds, greens, and softer tones spread across reef surfaces. Some corals possess fluorescent proteins that cause them to glow beneath ultraviolet light. Under certain conditions, reefs can seem lit from within, as though the coral itself carries hidden fire. Such glowing may have biological roles still being studied, linked in some species to protection from light stress or other subtle functions. Even after much research, reefs keep some mysteries. Among coral branches and crevices live bioluminescent organisms as well, creatures capable of producing their own light. Tiny flashes in dark water, drifting sparks among coral shadows, reveal that even the reef at night can carry hidden illumination. When daylight fades, the reef does not simply go dark. It becomes another world. Night transforms coral reefs in remarkable ways. During daylight, many corals appear still, their feeding tentacles withdrawn. But after dark, many polyps extend tentacles into moving water, feeding from currents carrying tiny life. A reef that seemed almost stone by day reveals itself at night as countless tiny animals opening to feed. This daily rhythm, expansion at night, quiet withdrawal by day, adds another hidden pulse to reef existence. Many fish also shift behavior with darkness. Some retreat into protected sleeping places. Some species create remarkable forms of nighttime protection. Certain fish surround themselves in mucus cocoons while they rest, masking scent from predators or parasites. Even sleep on the reef can involve strange adaptations. Other creatures become active only when daylight fades. Octopuses may move among coral reef forms in search of prey. Moray eels emerge from crevices. Nocturnal hunters begin patrolling spaces that seemed calm by day. The reef after sunset becomes a second ecosystem layered over the first. There is also wonder in the reproductive rhythms of coral itself. Some coral species reproduce through one of the most remarkable events in the sea, mass spawning. At certain times, often linked to moon cycles and seasonal cues, countless corals release eggs and sperm into the water at nearly the same time. The sea may grow cloudy with drifting life. What was still reef becomes a vast floating event of creation. These spawning events can feel almost miraculous. Colonies spread across large areas acting in synchrony, responding to ancient rhythms of moonlight, season, and temperature. Life rising together into currents. New generations beginning in the open sea. Few spectacles in nature are as strange or beautiful. And coral has other paths of renewal as well. Some species reproduce asexually through budding, where new polyps form from existing ones. Broken fragments may settle, reattach, and grow into new colonies. Even damage can sometimes become beginning. Reefs contain many ways of continuing life. Coral larvae drifting in ocean currents add another wonder. Tiny, nearly invisible, they may travel before settling onto hard surfaces where new colonies begin. Entire reef futures may start as drifting life too small to notice. This scale shift from tiny larvae to great reef forms remains one of the recurring marvels of coral worlds. There are countless other strange lives woven through reef spaces. Giant clams resting among coral can live for more than 100 years. Cleaner organisms maintain stations visited by larger fish. Some reef species can change sex during life, adapting reproductive roles as conditions demand. Some creatures are found nowhere else on Earth, but within certain reef systems. A single reef can hold biological stories, almost without end. And then there are the reef microhabitats, tiny worlds within worlds. A crevice no wider than a hand may shelter species living almost entirely there. Small differences in shade, current, or coral form can create miniature environments supporting distinct communities. The reef repeats a pattern seen across nature, that richness often lies in fine detail. Nowhere is this abundance more striking than in regions such as the Coral Triangle in Southeast Asia, often regarded as the most diverse reef region on Earth. More than 600 species of reef-building corals occur there. Diversity on such scale can feel almost beyond comprehension. It suggests reefs are not singular ecosystems, but countless variations of living complexity. There is something deeply soothing in contemplating how much quiet order lies beneath what first appears as dazzling abundance. Colors are communication. Night has rhythms. Spawning follows lunar timing. Tiny larvae drift with currents. Life unfolds through pattern. Yet reefs are not all gentleness. Some strange forces can become destructive. Crown-of-thorns starfish feed on coral tissue, and outbreaks can devastate reefs. Competition remains part of reef reality. Even beauty includes tension. This too belongs to living systems. Still, what lingers most is wonder. Corals glowing under unusual light, moon-guided spawning clouds, fish sleeping in protective cocoons, hidden bioluminescence among reef shadows, tiny larvae beginning future reefs. Such things make coral ecosystems feel almost dreamlike while remaining entirely real. And beneath all these marvels lies another truth. Such remarkable living worlds can face pressures from warming seas, acidifying waters, runoff, and other forces difficult for reefs to absorb quickly. The strange beauty explored here carries with it the question of resilience. How reefs endure pressure, recover from damage, and face growing challenges becomes the next part of their story. From the luminous hidden wonders of reef life, the story now turns toward the pressures coral reefs face and the resilience they still hold. For all the beauty and resilience of coral reefs, they exist within a changing world and respond to pressures both ancient and newly intensified. Yet the story of these pressures is not simply a story of loss. It is also a story of endurance, recovery, adjustment, and the remarkable ways reef systems persist through disturbance. Coral reefs have never been motionless worlds, untouched by challenge. Storms have broken coral for ages. Predators have fed upon reefs long before humans studied them. Sea levels have risen and fallen. Reefs have always lived with change. What is striking is how they endure through it. One pressure arises through the chemistry of seawater itself. Corals build their skeletons from calcium carbonate, drawing dissolved materials from the sea to create the stone architecture supporting reef life. Yet changes in ocean chemistry can make this process harder. As carbon dioxide levels rise in the atmosphere, more dissolves into seawater, gradually lowering ocean pH in a process called ocean acidification. The word sounds severe, though the sea remains alkaline. What changes is subtle chemistry, yet subtle chemistry can matter greatly to creatures building skeletons grain by grain. For corals, this can make growth more difficult. A reef already built over centuries depends upon continuing construction at its living surface. If skeletal building slows, the patient upward work of reef growth may be affected. This reminds us again how much immense reef forms can depend upon tiny processes hidden from view. Even chemistry dissolved in water can shape the future of reefs. There are pressures from land as well as sea. Sediment carried from rivers or disturbed shorelines can drift over reefs and smother coral surfaces. Water that appears clouded with suspended particles may reduce sunlight reaching the algae living within coral tissues. Because reef building depends so deeply upon light, sediment can affect more than appearance. It can influence the very partnership sustaining coral life. There are other subtle pressures too. Certain chemicals washed into coastal waters have been shown to affect coral larvae and other fragile early life stages. Tiny drifting larvae settling to begin future colonies may face challenges invisible to anyone looking across the sea. Once again, the smallest scales matter. And yet reefs have remarkable resilience. This deserves emphasis because reefs are too often spoken of as only fragile. Corals can recover from disturbance. Damaged areas may regrow. Broken fragments can sometimes establish new colonies. Fish communities may help support recovery through grazing that keeps algae from overwhelming recovering coral. Recovery may take years or decades, sometimes longer, but recovery is part of reef history. Storms offer a good example. Powerful storms can break coral reef forms and scatter fragments. At first, this seems wholly destructive, yet storms may also open surfaces where new coral settlement can occur. Broken spaces may become places of renewal. Disturbance and opportunity can sometimes arrive together. Nature often works this way. Even predators, though they can seem threatening, belong partly to reef dynamics. Crown of thorns starfish feed on coral tissue, and outbreaks can devastate reefs, yet in balanced conditions, they are also part of reef ecology. Complexity often resists simple categories of good and bad. Reefs are shaped through interactions. There is also human ingenuity entering this story in interesting ways. Artificial reefs have sometimes been created to help restore habitat or support marine communities. Reef forms placed in suitable waters may become colonized by corals, fish, and other organisms over time. Even shipwrecks can become thriving artificial reefs, their surfaces transformed into living marine architecture. A lost vessel may become habitat. Again, destruction and renewal sometimes meet. Some of the most important support for reefs comes from neighboring ecosystems. Mangrove forests and seagrass beds often help protect nearby coral systems. Mangroves can trap sediments before they reach reefs. Seagrass meadows help support water clarity and serve as habitat for species that later move onto reefs. Many juvenile fish spend early life in mangroves before migrating to coral ecosystems. Reef life often begins elsewhere. This reveals that reefs are not isolated wonders. They are part of larger coastal networks. There is something beautiful in this interconnectedness. Coral, seagrass, mangrove, fish nurseries, currents, microorganisms, all linked. The reef is never only itself, it belongs to a wider living system. Even microorganisms play crucial roles. Tiny unseen communities help recycle nutrients with remarkable efficiency. This helps explain how reefs thrive in waters often poor in nutrients. Recycling happens so effectively that scarcity becomes abundance. Invisible processes sustain visible richness. This pattern repeats again and again in reef life. Some reef-building corals, called hermatypic corals, form the hard reef forms most associated with tropical reefs. Others, soft corals, do not build massive skeletons but add motion and color to reef communities. Together they show the diversity within coral life itself. And then there are the coral forms shaped for different conditions. Brain coral with its folded ridges, staghorn coral branching like underwater antlers, elkhorn coral spreading in broad reef forms that can grow surprisingly fast compared with many corals. Form becomes strategy. Strategy becomes habitat. Resilience often lies partly in such diversity. A reef made of many forms and many relationships may respond differently to disturbance than a simpler system. Diversity can be a kind of strength. There is calm perspective in remembering how old reefs are. Some began forming more than 8,000 years ago. During the last ice age, many reefs stood exposed when sea levels were lower. Later rising seas allowed coral expansion again. Reefs have already lived through immense planetary changes. Their history carries lessons in persistence. Some reefs can even grow upward to keep pace with rising seas, provided growth can continue and conditions remain supportive. This ability feels almost symbolic, life rising with changing waters. And still, pressures remain real. Reefs are often described as among the most threatened ecosystems on Earth. That phrase can sound heavy, yet within it is also recognition of value. Things threatened are often things precious. Coral reefs matter profoundly, ecologically, scientifically, and to human communities relying on them. Millions of people depend on reefs for food and income. Reef tourism supports livelihoods around the world. Reef organisms have contributed compounds studied in medicine. These living systems matter far beyond the sea itself. There is another quiet resilience often overlooked. Herbivorous fish grazing reefs help prevent algae from overtaking coral. Small daily acts of feeding support ecosystem balance. Even ordinary behaviors help sustain recovery. And recovery does happen. Damaged reefs can return, not quickly, not always fully, but coral growth resumes. Fish communities rebuild. Life recolonizes broken spaces. There is patience in reef recovery, as in reef construction itself. That is one of the deepest lessons here. Coral reefs are built slowly. They recover slowly. Their tempo is patient. Human attention often seeks dramatic moments. Reef resilience often works through long, quiet persistence. Yet beyond pressures and recovery lies another remarkable truth. Reefs do not stand alone in tropical seas. They connect to wider webs of life, ancient coral lineages, deep water coral worlds, and some of the most diverse marine regions on Earth. From resilience under pressure, the story now widens again toward the broader living networks reefs belong to, and the remarkable diversity that extends far beyond any single coral garden. Coral reefs can seem at first like self-contained worlds, bright underwater cities rising from tropical seas, yet they are part of much larger living networks, extending far beyond the reef itself. No reef exists entirely alone. Coral systems are linked to mangroves, seagrass meadows, ocean currents, migrating species, microorganisms, and ancient coral lineages stretching through time. To understand reefs more fully is to see them not as isolated wonders, but as living webs woven into broader marine worlds. Along many tropical coasts, mangrove forests stand at the boundary where land meets sea. Their roots rise through shallow water in tangled reef forms, sheltering countless young fish and invertebrates. For many reef species, these mangroves serve as nurseries, places of protection in early life, before individuals move outward to coral reefs. A fish, gliding among reef corals as an adult, may once have sheltered among mangrove roots. Life on the reef often begins elsewhere. There is something elegant in this sequence. Mangroves shelter the young, seagrass meadows provide feeding grounds, coral reefs support adult communities. Different habitats linked through life cycles form a larger coastal system. The reef depends partly on places beyond the reef. Seagrass beds play their own quiet role. Their underwater meadows help stabilize sediments, support water clarity, and provide habitat for many creatures moving between ecosystems. Some fish spend time in seagrass before shifting toward reef life. Sea turtles may feed there before moving across coral landscapes. These connected habitats act almost as neighboring districts within a greater marine world. Currents deepen these connections. Ocean currents carry coral larvae, fish larvae, nutrients, oxygen, and drifting life between places often separated by vast distances. A coral colony on one reef may contribute larvae that settle far away. Reefs exchange life through moving water. What seems separate may be biologically connected across the sea. There is wonder in imagining reefs linked not by roads or visible paths, but by currents carrying life. Microorganisms form another hidden network. Bacteria, tiny plankton, and other tiny organisms help cycle nutrients with remarkable efficiency. Coral reefs often flourish in nutrient-poor waters because so much is conserved and reused through these invisible processes. Tiny life sustains larger life. Again, the reef reveals how much abundance depends upon what is rarely seen. Reef-building corals themselves hold remarkable diversity. Hard reef-building corals, called hermatypic corals, create much of the stone reef form associated with tropical reefs. Soft corals move more gently in currents and add another layer of reef form and color without building massive skeletons. Together they show coral is not one simple form, but a varied lineage of life strategies. Some forms have become iconic. Brain coral with ridged patterns like folded living stone, staghorn coral branching outward in dense antler-like growth, elkhorn coral spreading broad reef forms that can grow relatively quickly. Each form creates different shelter, influences currents differently, and supports distinct communities. Shape becomes ecology, and reefs exist in remarkable variety across the planet. The Coral Triangle in Southeast Asia is often regarded as the most diverse reef region on Earth. More than 600 species of reef-building corals live there, along with remarkable numbers of fish and invertebrates. It is sometimes called the center of marine biodiversity, and for good reason. Diversity there can feel almost beyond counting. There is something humbling in realizing reefs exist in more than 100 countries worldwide. Though often imagined as scattered tropical jewels, they form a planetary network touching many seas and cultures. Their story is global, and coral life does not end in warm, shallow waters. This surprises many people. Cold water coral reefs exist in deep, dark ocean environments where sunlight never reaches. These corals do not rely on photosynthetic algae as tropical reef builders do. They live through other strategies, sometimes in cold currents along continental slopes or deep underwater ridges. Some deep-sea corals may live for thousands of years. This stretches the imagination. Ancient coral life in darkness, growing slowly in cold water, far from tropical lagoons, yet linked through deeper coral history. Coral worlds are broader than sunlight reefs alone. Some reefs began forming more than 8,000 years ago, as rising seas after the last ice age flooded continental shelves. Earlier reefs in some places stood exposed when sea levels were lower. Then waters rose, and coral expanded again. Reefs carry these long environmental histories within them. Even carbon cycles touch reef story. Coral skeletons store calcium carbonate, linking reefs in subtle ways to planetary chemistry. Once again, these ecosystems prove larger in significance than their beauty alone suggests. And there are countless marvels in reef inhabitants still. Some fish sleep in mucus cocoons for protection. Octopuses hunt among coral reef forms using intelligence and camouflage. Tiny crevices create microhabitats where species may exist nowhere else. Every scale reveals complexity. Herbivorous fish grazing algae help maintain reef balance. Without them, coral may struggle against algal overgrowth. Small acts of feeding help preserve whole systems. On reefs, ordinary behaviors often hold ecosystem-scale importance. Natural lagoons formed between barrier reefs and land create calmer waters, supporting nurseries and distinct communities. Currents moving through reefs deliver oxygen and drifting food to coral polyps. Even sound belongs to reef life. Reef fish often use sound to communicate, and healthy reefs can carry rich underwater soundscapes of crackling shrimp and calling fish. A reef is not silent. It hums with hidden acoustics. There is deep calm in realizing how much of reef life is relationship. Coral with algae, reefs with mangroves, fish with seagrass nurseries, species linked by currents, microbes recycling nutrients, predators balancing grazers. It is all connection. And this web extends through time as well as space. Ancient reefs exposed during ice ages, rising seas allowing expansion, corals growing upward with changing waters, life adapting through long planetary rhythms. This is one of the great quiet revelations of coral reefs. They are not isolated spectacles, but living networks embedded in wider ecological and geological systems. To study reefs is to keep discovering connections. Yet these ancient connections lead toward another vast dimension of reef story, time itself. Corals hold records within their skeletons. Growth rings preserve history. Reefs can reveal past climates and ocean temperatures written silently in stone. From living networks across the sea, the story now turns toward reefs as archives of time, where coral begins recording the memory of oceans. Coral reefs are often admired as living ecosystems, yet they are also archives. Within coral skeletons, time can be recorded with remarkable subtlety. What appears to be stone built slowly by tiny animals can preserve traces of seasons, ocean temperatures, storms, and environmental change stretching back through centuries and in some cases far longer. A coral reef is not only alive in the present, it carries memory. Some massive corals grow in layers that can be read in ways resembling tree rings. As growth varies through seasons and conditions, bands form within the skeleton. Scientists can study these growth patterns to estimate age and to understand changing environmental conditions over time. It is remarkable to think that a coral colony may quietly record years and decades as it grows, preserving a history no human hand intended to write. These growth bands offer one of the most intimate ways life records time. Trees hold time in wood, ice holds time in layered snowfall, corals hold time in stone built by living animals beneath the sea. Each growth layer is small, yet together they become chronology. Coral skeletons can preserve evidence of past ocean temperatures as well. Chemical signatures within coral layers may reflect conditions in the water when those layers formed. In this way, corals can serve as climate archives, helping scientists understand ocean histories extending before modern measurements existed. Reefs do not only respond to changing seas, they can help reveal how seas have changed. There is something deeply fitting in this. Corals have lived through long environmental shifts, and within their own reef forms they carry traces of those histories, life preserving memory through growth. Storms too may leave signatures in reef form. Powerful storms can break coral, rearrange reef surfaces, and alter patterns of growth. Yet storms can also create openings where new coral may settle and expand. Disturbance may leave marks, while also shaping future reef development. Once again, reef history often holds destruction and renewal together. The story of reefs through time stretches far beyond recent centuries. Some reef systems began forming more than 8,000 years ago as rising seas after the last ice age flooded continental shelves. Coral expanded into newly suitable shallow waters, building reefs still growing today. Yet coral history reaches much deeper than even these modern reefs. Reef-building organisms have existed in changing forms across immense spans of geological time. During lower sea levels in the Ice Age, many reefs stood exposed above water. Later rising seas allowed coral growth to spread again. This ability of reefs to respond to changing seas is one reason they have persisted so long. Reefs are shaped by change, not merely threatened by it. Some reefs can even grow upward to keep pace with rising waters, provided growth remains strong enough and conditions allow. This image is quietly powerful. As seas rise, reefs may rise too, living reef forms responding through patient construction. Few ecosystems embody adjustment in such literal form. There is also deep time hidden in deep sea corals. Some cold water corals may live for thousands of years, far older than many tropical colonies. Growing in dark cold currents, they extend coral history into places few imagine. Coral time is broader than warm, shallow reefs alone suggest. And reefs do not merely record climate. They influence planetary processes in subtle ways. Coral skeletons store calcium carbonate, linking reefs to long carbon cycles. Once again, these ecosystems prove larger in significance than their beauty alone reveals. There is wonder in realizing a coral colony may hold records of warm years, cooler years, storms, shifting chemistry, even events occurring before modern nations formed. To swim above coral may be to move above living history written in limestone. Some scientists read coral records much as others read old manuscripts, chemical traces, growth bands, structural changes, all offering clues. The reef becomes not only ecosystem, but document, and yet while coral records deep time, life on the reef also unfolds in daily rhythms. Some fish retreat into nighttime mucus cocoons, others hunt among coral shadows. Currents deliver food to waiting polyps. Tiny sounds pass through reef waters. Time exists there at every scale, the daily, the seasonal, the ancient. Reef fish often use sound to communicate, and reefs themselves can carry intricate soundscapes. Crackling from shrimp, calls from fish, rhythms of feeding and movement. Even sound may carry patterns linked to healthy reef communities. A reef can be heard as well as seen. There is calm beauty in thinking of reefs as places where many forms of time meet. The pulse of feeding polyps at night, lunar timing, guiding coral spawning, seasonal growth recorded in skeleton bands, millennia shaping reef forms, deep geological ages holding coral history beyond imagination. Few places hold so many layers of time together. And through all this, reefs remain living systems, not museums. They continue growing, responding, recording. Time in coral is never merely past. It is ongoing. This perspective changes how one sees a reef. Not just colorful habitat, not just biodiversity, but living archive, living architecture, living memory. Yet coral records also tell another story. They reveal that reefs are among the most threatened ecosystems on Earth, and that understanding their history deepens the urgency of protecting them. Because reefs hold such richness, such ancient memory, and support so much life, efforts to conserve and restore them have become a story of their own. Millions of people depend on reefs. Countless species depend on them. Their loss would change oceans and coasts profoundly. Yet around the world, there are efforts to protect reef systems, restore damaged habitats, and preserve this ancient living inheritance. And beyond their ancient history and living complexity lies the human relationship with reefs, the food they support, the communities they protect, the medicines they may inspire, and the conservation efforts now gathering around them. From reefs as archives of ocean memory, the story now turns toward reefs and people, and the shared future tied to these remarkable living seas. For thousands of years, human communities have lived beside coral reefs, drawing food, protection, and livelihood from these living marine landscapes. Though reefs may seem remote wonders belonging only to divers or distant tropical seas, they are woven deeply into human life. Millions of people depend upon coral ecosystems in ways both visible and subtle. Reefs feed coastal communities, help shelter shorelines from storms, support fisheries, inspire medicines, and sustain cultures shaped by the sea. Their story has never belonged only underwater. It reaches onto land. One of the most direct ways reefs support people is through food. Many fish species spend part of their lives among coral reefs, feeding, sheltering, and reproducing there. For countless coastal communities, reef fisheries provide vital nourishment. The abundance of reefs has supported human societies for generations, often in places where marine resources are central to daily life. A reef is not only a place of beauty, It can be a living pantry shaped by ancient ecological balance. And this abundance depends on complexity. Reef fish are not merely resources gathered from the sea. They are part of intricate communities shaped by coral reef form, predators, grazers, nursery habitats, and currents carrying life between places. Human reliance on reefs is therefore tied to the health of the whole ecosystem. To depend on reefs is, whether consciously or not, to depend on ecological relationships. Reefs also protect people in quieter but profound ways. Coral reef forms act as natural breakwaters, reducing wave energy before it reaches shore. This can lessen coastal erosion and reduce damage during storms. Across tropical regions, reefs help buffer shorelines against powerful seas. It is remarkable to think that tiny coral polyps, building limestone grain by grain over centuries, help defend human communities from waves and storm surge. There is something deeply moving in that hidden service. Living marine animals building reef forms that soften storms long before people named such processes. Nature often performs protective work quietly. For many coastal communities, reefs support livelihoods beyond fishing as well. Reef tourism generates billions of dollars annually and sustains work for guides, boat operators, researchers, conservation workers, and many others. People travel from around the world to witness coral reefs because few ecosystems match their beauty and life. Entire local economies in some regions are intertwined with healthy reefs. Yet reefs offer more than food and income. They have contributed to science and medicine in remarkable ways. Compounds derived from reef organisms, including some sponges and other marine life, have been studied for possible medical use, including cancer research. This remains one of the more remarkable dimensions of biodiversity, that creatures growing quietly in coral ecosystems may hold chemical compounds useful far beyond the sea. This is part of why reef biodiversity is often compared with tropical rainforests, in richness of life, in hidden relationships, and in biological potential. Reefs stand among Earth's great reservoirs of living possibility. There is also cultural meaning in reefs. For many island and coastal peoples, reefs belong not only to ecology or economy, but to memory, identity, and place. Knowledge of reef channels, fish behavior, tides, and seasons may pass across generations. Reefs can be woven into stories, navigation traditions, and ways of living close to the sea. Such human relationships with reefs are harder to measure than fish populations or tourism revenue, yet they matter deeply. And reefs themselves support remarkable biological behaviors still unfolding around these human connections. Some reef fish can change sex during their lifetimes, adapting in ways that still fascinate biologists. Cleaner rasa operate cleaning stations visited by larger fish in relationships so orderly they almost seem social institutions within reef communities. Such details remind us how much wonder remains even in well-studied ecosystems. There are also forces capable of unsettling reef balance. Crown-of-thorns starfish, natural reef inhabitants, can in outbreaks consume vast areas of coral tissue. Such events reveal how dynamic reef systems are. Balance is not static, it is maintained through interacting forces, yet reefs can recover. This is worth returning to. Recovery may take decades, but damaged reefs can regrow. Fish communities can return, and living reef form can rebuild. Patience belongs to reef resilience as much as to reef formation. Artificial reefs have become one expression of human effort to support marine habitats. Reef forms intentionally placed underwater may become colonized by corals and fish over time. Even shipwrecks can transform into thriving reef communities. There is something poetic in abandoned human reef forms becoming habitat for marine life. And still, reefs depend not only on direct conservation, but on broader connected habitats. Mangroves and seagrass beds often protect and support nearby coral systems. Many juvenile fish begin life in mangrove roots before moving to reefs. Again, the theme returns. Reefs are never isolated. There is calm perspective in recognizing how deeply human life and reef life intersect. Food, coastal protection, livelihoods, medicine, cultural memory, all linked to living coral systems built by tiny animals over ages. It is one of those truths that seems almost too large to hold fully in mind. And yet reefs remain among the most threatened ecosystems on Earth. This recognition has inspired growing conservation efforts around the world. Marine protected areas, reef restoration, scientific monitoring, and global efforts to protect coral systems all reflect a widening awareness that reefs matter profoundly. Hope lives partly there, in care, in restoration, in knowledge joined with protection. There is also something encouraging in the reefs themselves. Their history shows persistence through immense change. Their biology holds resilience. Their recovery, though often slow, is real. Coral reefs are not simply symbols of fragility. They are symbols of endurance. Still, the story of reefs stretches beyond tropical shallows and human shores. There remain deeper coral worlds, ancient coral regions of remarkable diversity, and reef frontiers that widen our sense of what coral life can be. From the human relationship with reefs, the story now turns outward again, towards some of the most remarkable coral realms on Earth, including the great diversity of the coral triangle and the hidden worlds of deep-sea corals. Beyond the familiar image of tropical reefs glowing in shallow blue water lies a wider coral world far more expansive than many imagine. Coral life reaches into regions of remarkable diversity and even into dark ocean depths where sunlight never arrives. To move outward into these coral frontiers is to discover that reefs are not singular places, but many worlds shaped in very different ways. Some hold the greatest concentration of marine diversity on Earth. Others exist in cold darkness, where coral grows in silence over centuries. Together they widen the story of reefs into something almost planetary. Among the most remarkable coral regions is the Coral Triangle of Southeast Asia, often described as the center of marine biodiversity. Spanning waters around Indonesia, the Philippines, Malaysia, Papua New Guinea, the Solomon Islands, and Timor-Leste, this region contains more than 600 species of reef-building corals, more than anywhere else on Earth. That number alone is remarkable. In one region of the sea lives a vast share of the coral diversity known in the world. And with coral diversity comes remarkable abundance of life. Thousands of reef fish species move through these waters. Countless invertebrates fill coral reef forms. Predators patrol reef slopes. Tiny hidden species inhabit crevices no wider than a hand. The richness can seem almost inexhaustible. There is something humbling in imagining waters so diverse that a single reef may hold forms of life found nowhere else. Endemism, species unique to particular places, gives reefs part of their wonder. Some creatures belong to one reef region and nowhere beyond it. Such uniqueness makes each coral region feel like a world unto itself. The coral triangle is often called the Amazon of the seas, though even that comparison struggles to contain its complexity. Here, coral architecture, warm currents, island geography, and evolutionary history have combined over immense spans of time to create remarkable diversity. It is one of Earth's great living concentrations. There is calm beauty in imagining these reefs extending across clear tropical seas, branching corals rising like underwater forests, fish clouds shifting over reef slopes, currents carrying life among islands. It feels almost endless, yet even this tropical abundance is only part of coral's story. Beyond warm, sunlit reefs lie cold water coral systems in deep, dark oceans, and these can feel like another realm altogether. Cold water corals do not rely on photosynthetic algae because sunlight does not reach them. They live in darkness, often along continental margins, submarine ridges, and deep currents carrying nutrients through cold water. Their growth strategies differ, yet they too build intricate coral reef forms supporting marine communities. Many people are surprised such reefs exist at all. Coral has become so associated with tropical color that deep-sea corals can seem almost improbable. Yet some have persisted for remarkable lengths of time. Certain deep-sea corals may live for thousands of years, among the longest-lived animals known. There is quiet awe in that thought. Ancient corals growing slowly in darkness, while empires rise and vanish above the sea. Deep water coral habitats support their own communities of fish and invertebrates, suited to life in cold, dim conditions. Though far removed from tropical lagoons, they reveal coral as a broader expression of life than shallow reefs alone suggest. This widening perspective changes the story. Coral is not just warm water brilliance. It belongs also to cold ocean depths. Diversity includes both. There are other frontiers too. Reefs exist in more than 100 countries, tracing coastlines and islands across much of the tropical world. Each region holds variations shaped by local waters, currents, species histories, and geological setting. No two reefs are quite the same, and reefs continue changing through time. Storms may break coral, but also create openings where new growth can begin. Herbivorous fish help prevent algae from overtaking reefs, maintaining conditions that support coral recovery. Reefs persist partly through these balancing forces. Natural lagoons formed by reefs create calm internal waters, often rich with young marine life. Outer reef slopes may host very different communities than sheltered lagoon shallows only a short distance away. Even within one reef system, diversity multiplies through changing habitats. There is also the subtle world of currents moving through coral reef forms. Underwater currents deliver oxygen and drifting food to waiting polyps. They carry larvae. They shape growth forms. They connect reefs in ways unseen from above. Water itself is part of reef architecture, and reefs have soundscapes. This is one of the quieter marvels. Healthy reefs often carry a living chorus of snapping shrimp, fish calls, and countless small acoustic signals. Some reef fish use sound to communicate. A reef can shimmer visually by day and hum invisibly with life. There is something soothing in imagining these layered realities. Color, current, sound, hidden deep reefs, tropical coral frontiers, ancient dark water colonies. The story keeps widening, and yet for all this diversity, coral worlds share certain themes: slow growth, interdependence, hidden resilience, life-building reef form supporting abundance. Whether in warm lagoons or cold darkness, those patterns return. This is one of the deepest revelations reefs offer. The more closely they are studied, the larger they become. What begins as coral gardens near shore opens into planetary networks, ancient lineages, and living worlds beyond ordinary imagination. But the story of reefs is not only about their remarkable breadth, it is also about what these ancient systems can teach. Corals record climate in growth rings. Reefs reveal resilience through recovery. Their ecological balance offers lessons in cooperation, adjustment, and the power of diversity itself. And these lessons lead naturally toward the future, because understanding reefs eventually asks what becomes of these remarkable systems in a changing world, and what role conservation may play in protecting them. From coral frontiers stretching from tropical abundance into ocean darkness, the story now turns toward reefs in the future and the growing efforts to protect these ancient living worlds. To understand the future of coral reefs, it helps first to remember what reefs truly are. They are not scenery alone. They are ancient living systems built through patience, cooperation, competition, recovery, and remarkable diversity. They have endured storms, changing seas, predators, geological shifts, and long environmental change. Their history is not one of stillness, but of persistence through disturbance. That history matters because it reminds us that reefs possess resilience even as they face pressures requiring care. Much of the future of reefs now turns on conservation, though conservation is not one single effort, but many kinds of attention working together. Some efforts focus on protecting reef habitats from direct damage through marine protected areas where fishing or destructive activities are limited. In such places, ecological relationships may remain stronger, herbivorous fish can continue grazing, predators can help maintain balance, and coral communities may hold greater resilience. Other efforts focus on reef restoration. In some places, coral fragments are grown in nurseries and later attached to damaged reefs to help support regrowth. Researchers study coral species that may tolerate stress better under certain conditions. Restoration is not magic, and reefs are too complex to be rebuilt quickly by human hands. Yet such efforts reflect a growing willingness to work with reef life rather than simply observe its decline. There is quiet beauty in coral gardening as an idea. People tending fragments of ancient marine builders, helping life resume where damage occurred. It feels almost humble compared with the vastness of the sea, yet meaningful precisely for that reason. Science has also deepened understanding of how reefs recover naturally. Herbivorous fish protecting coral from algal overgrowth. Mangroves and seagrasses supporting reef health from nearby habitats. Larvae carried by currents recolonizing damaged areas. Conservation increasingly recognizes that protecting reefs often means protecting these wider relationships too. This widening view matters. A reef is not saved only at the reef. It may be supported through healthier coastlines, clearer waters, protected fish populations, and stronger connected habitats. Once again, the great reef lesson returns. Everything is linked. Global conservation efforts now stretch across many scales. Local reef stewardship by coastal communities, marine reserves protecting biodiversity, scientific monitoring tracking reef change, international efforts aimed at preserving coral systems. The scale of response reflects the scale of reef importance. And reefs themselves offer reasons for hope through resilience. Some damaged reefs have recovered over time. Coral growth has resumed in places once heavily disturbed. Fish communities have returned where pressures eased. Recovery can be slow, often measured in decades, but slow recovery is still recovery. Patience, which defines reef construction, often defines reef healing as well. Some researchers study whether certain coral populations show tolerance to warmer conditions or other stresses. This work explores not only vulnerability, but responsive possibility. Nature is often more dynamic than first assumed. Coral history itself suggests adjustment has long been part of reef survival. And still, conservation is not only scientific, it is also philosophical in a quiet way. It asks what humans choose to value. Coral reefs, among the most diverse ecosystems on Earth, ask whether beauty, complexity, and ancient living systems deserve care, not because they are useful alone, but because they are remarkable. There is also growing recognition that reefs support far more than biodiversity. They help sustain coastal communities, fisheries, tourism, medicine, and shoreline protection. To care for reefs is also to care for many human futures tied to them. Without coral reefs, ocean biodiversity would be dramatically changed. Many coastal communities would be changed as well. This truth gives reef conservation a human dimension as well as ecological one. There are encouraging stories too. Marine protected areas where fish populations recover, restoration sites where coral growth returns, communities protecting reef resources through long local knowledge, scientists uncovering new understanding of coral resilience. Hope on reefs is rarely loud. It often looks like patient work. There is calm in imagining a damaged reef slowly recovering, new coral growth extending over old skeleton, fish returning to branching shelter, grazers maintaining balance, life recolonizing broken places. Recovery in reefs can feel like an underwater expression of renewal itself. Yet even as the future asks for care, reefs continue offering lessons beyond conservation. Their interdependence teaches something about living systems generally. Diversity can be strength. Cooperation can support abundance. Slow growth can create immense beauty. Hidden processes can shape entire worlds. Reefs are not only ecosystems to protect, they are places from which to learn. This is why coral reefs stir such fascination. They hold wonder, fragility, resilience, and wisdom together. And as reflection deepens, it feels natural to widen from conservation into larger questions. What do reefs reveal about life, time, and the sea itself? What does it mean that tiny animals build reef forms visible from space? That ancient systems rise from cooperation, that worlds of dazzling complexity grow through patience. From efforts to protect reefs in the future, the story now turns toward those larger reflections, where coral reefs become not only subjects of science and conservation, but symbols of living beauty shaped through time. To spend time thinking about coral reefs is to begin seeing them as more than ecosystems. They become reflections on how life builds, cooperates, adapts, and endures through immense spans of time. Tiny coral polyps, soft-bodied animals scarcely noticed on their own, create reef forms visible from space. That fact never loses its wonder. It suggests something profound about how great things may arise through small, repeated acts. Reefs do not emerge through speed or force. They emerge through patience. A fraction of an inch of growth in a year can seem almost nothing, yet through centuries it becomes reef walls, lagoons, and living reef forms sheltering vast communities. There is calm in that lesson. Much in human life moves with urgency, while coral reefs move by another rhythm entirely. They remind us that quiet processes can shape worlds. They also reveal the power of cooperation at every scale. At the heart of every reef lies relationship. Coral and algae sustain one another. Fish and cleaners maintain hidden balances. Grazers keep algae from overtaking coral. Mangroves, seagrasses, currents, and reefs form broader living networks. Reef abundance is not built through isolation. It rises through interdependence. Diversity does not weaken reefs, it strengthens them. Countless species sharing reef form, competing, balancing, sheltering, feeding, and reproducing together create resilience through complexity. A reef suggests that richness often grows where many forms of life coexist in relationship. There is wisdom in that. Some of the strongest systems in nature are not simple, but wonderfully intricate. Reefs reveal something about fragility often misunderstood. Fragility does not mean weakness. Coral can be delicate in one sense and remarkably enduring in another. Reefs have persisted through storms, sea level shifts, predators, geological change, and long environmental rhythms. They are sensitive, yet resilient. Those qualities are not opposites, they belong together. There is quiet beauty in that paradox. Some of the most enduring things in nature may also be finely balanced. Coral reefs carry that truth in living form. They endure not through hardness alone, but through adaptability, diversity, and patient renewal. Even damage may sometimes become part of regrowth. Broken coral fragments may seed new colonies. Storm-disturbed reefs may open space for fresh life. The reef often answers disruption, not simply with resistance, but with renewal. There is also something remarkable in the way reefs gather so many scales of life and time into one place. The smallest scale, tiny algae inside coral tissue. The largest scale, reef systems stretching across oceans. The shortest scale, a fish moving through coral branches in a moment. The longer scale, ancient coral growth unfolding through millennia. Few places gather so many dimensions together. To drift over a reef is almost to witness layers of existence at once. Immediate movement and ancient stillness, bright color and geological patience, daily feeding rhythms and deep time recorded in limestone. It feels less like observing a habitat and more like entering a living meditation on time itself. This is part of why reefs hold such fascination in human imagination. They feel both richly alive and quietly ancient, dynamic and serene, delicate and enduring. Few places hold seeming opposites so naturally. And there is something profound in the way reefs create abundance from apparent scarcity. Clear tropical waters may seem poor in nutrients, yet reefs become centers of remarkable life through recycling, efficiency, and cooperation. Even this carries a lesson. Richness can arise not only from excess, but from relationship and balance. Nature often builds abundance through elegance rather than waste. And then there is beauty itself. Coral colors, branching forms, lagoons, reef sounds, moon-guided spawning, hidden bioluminescence. Beauty on reefs is not decoration laid over life. It is woven into function, survival, and pattern. Coral forms shelter fish because of their shape. Color may conceal as much as dazzle. Sound carries communication. Spawning follows lunar rhythms older than memory. Their beauty belongs to how they live. Sometimes wonder teaches what analysis alone cannot. Coral reefs awaken that kind of wonder. They make visible the artistry of living systems. There is perspective too in remembering reefs existed long before human histories, and may, where protected and allowed, continue long beyond our own brief moment. They invite humility. Human life can feel hurried and central. Reefs suggest another scale in which patience, interdependence, and time matter deeply. They ask quiet questions. What grows slowly but endures? What hidden relationships support visible beauty? What worlds depend on foundations rarely noticed? Even the threats reefs face and the care they inspire add to this meaning. To protect reefs is not only to conserve biodiversity, it is to defend one of Earth's great expressions of living complexity. That carries moral beauty as well. There is something especially moving in the thought that creatures as small as coral polyps can build reef forms sheltering a quarter of all marine life. It overturns assumptions about scale and significance. Smallness does not mean insignificance. Reefs proclaim this in living stone, and the sea around them deepens the reflection. Currents moving through coral branches, sunlight wavering over reef slopes, fish weaving through labyrinths built over ages, sound crackling softly through living reef forms. One can almost feel why reefs have inspired awe for generations. They are not simply underwater places. They are reminders of what life can make when given time. In the end, coral reefs reveal a quiet truth running through much of nature. That beauty often rises through cooperation. That resilience may be patient. That abundance may depend upon relationships hidden from view. That what appears delicate may hold remarkable strength. There is comfort in such truths. And as the story moves toward its final arc, coral reefs stand not only as ecosystems of remarkable richness, but as symbols of living artistry shaped through time. Yet there remains one final reflection deeper still: the legacy reefs leave, and what their continued existence may mean for the future of life beside the sea. The legacy of coral reefs reaches far beyond the reefs themselves. Their influence moves through oceans, coastlines, climates, living communities, and human imagination. Few ecosystems give so much while asking so little attention in return. Quietly, over immense stretches of time, coral reefs have shaped the living world. They have sheltered a quarter of all marine life. They have buffered tropical shores from waves and storms. They have nourished human communities and inspired generations with beauty, almost beyond invention. To think about their legacy is to think about what enduring living systems give to the world simply by existing. Part of that legacy is biological abundance itself. Coral reefs have become cradles of evolution, places where diversity flourishes through countless relationships unfolding over deep time. Within reef systems, species have suited to niches so small they might seem impossible. A crevice may shelter one life, a coral branch another, a reef ledge another still. Such layered complexity has produced remarkable richness. In this sense, reefs are not simply places where biodiversity happens to exist. They are engines of biodiversity, shaping and sustaining life on remarkable scale. There is something profound in realizing that tiny coral animals, almost fragile when considered alone, help support 1/4 of all marine species. That number remains remarkable, no matter how often it is repeated. It overturns ordinary assumptions about significance. It reminds us that what appears small may carry immense consequence. Reefs offer this lesson again and again. Their legacy is geological as well as biological. Coral reefs help shape coastlines. They soften wave energy, slow erosion, and help create sheltered lagoons and beaches. In some places, entire shorelines owe part of their form to coral growth through ages. These reef forms, built by living creatures grain by grain, have become features of landscapes. There is wonder in that. Animals no larger than fingertips, helping shape the meeting place of land and sea. And there is a legacy of time held in reefs themselves. Ancient coral growth records past oceans. Reef formations preserve histories of changing seas. Some coral colonies have lived through centuries, some deep-sea corals through millennia. Coral reefs hold memory, not as metaphor alone, but in literal form. They are living archives of environmental history. Few ecosystems carry that kind of record while remaining vibrantly alive in the present. There is also legacy in what reefs teach. Their interdependence reveals something fundamental about life. Cooperation can support abundance. Diversity can strengthen resilience. Slow growth can build remarkable beauty. Hidden processes can sustain entire worlds. These are ecological truths, yet they feel larger than ecology. Reefs seem almost to teach by example. This may be why coral reefs have stirred such deep fascination in people who encounter them. They do not merely impress through color or abundance. They evoke wonder, and wonder itself may be part of their legacy. Human beings protect what they come to love, and often love begins in awe. There is legacy too in the lives shaped directly by reefs, coastal fishing communities, island cultures, generations who have navigated reef passages and known the rhythms of tide and current. Reefs have long been woven into human survival and memory. Their value is not measured only in species counts or shoreline protection, but in lives lived beside them. And there is the legacy still unfolding through science. Reefs have revealed principles about symbiosis, resilience, ecological balance, climate history, and adjustment. They continue teaching. Even now, much about coral life remains mysterious. A healthy reef still contains countless questions. That too is part of legacy, to continue inviting discovery. There is calm perspective in recognizing how much of Earth's beauty has been shaped through slow processes largely unseen. Forests grow quietly, mountains rise slowly, reefs build beneath water where many may never witness them. Yet their hidden work shapes worlds. Coral reefs belong among those great quiet makers. Their legacy also carries responsibility. To inherit something remarkable invites care. This is not a heavy thought, but a clarifying one. The future of reefs matters because their legacy already runs so deep. To protect reefs is not only to prevent loss, it is to allow living beauty, ancient complexity, and ecological richness to continue. And that is why reefs feel different from many natural wonders. They are not only admired, they seem cherished. There is something moving in imagining coral polyps continuing their slow building tonight beneath tropical seas. Fish moving through coral branches, currents delivering food to feeding tentacles, moonlight touching reefs where spawning may one day begin again. Life continuing through ancient rhythms. The reef does not know it is admired. It simply persists in being what it is. That may be part of its deepest legacy, a reminder that beauty can arise through ordinary acts, repeated faithfully over time. A reminder that resilience may look like patient growth. A reminder that life often becomes richest through connection. In the end, coral reefs leave a legacy not only in oceans, but in imagination. They show what living systems can become when cooperation, time, and diversity work together. They show that fragile-appearing things may hold immense strength. They show that quiet builders may shape worlds. Those quiet builders do not shape reefs alone. They shape living worlds where countless other builders, grazers, hunters, and scavengers help sustain the reef through constant activity. A coral reef may appear serene from above, yet within its reef form, life is always altering, maintaining, testing, and renewing the system. Much of reef stability depends not on stillness, but on this motion. Among the most important of these living architects are herbivorous fish. Parrotfish move over reef surfaces, grazing algae that might otherwise spread across coral and reduce space for new growth. Their feeding helps maintain balance in ways easy to overlook. Day after day, they scrape algae from reef surfaces, opening places where coral larvae may settle and where living coral can continue expanding. This ordinary feeding behavior supports the future reef form of the reef. Parrotfish shape more than coral growth. As they graze, they grind pieces of old coral skeleton into fine carbonate particles. Over time, this contributes to tropical sands. Some bright white beaches owe much of their sand to generations of reef fish carrying out this quiet work. Even coastlines can hold the imprint of reef grazers. Surgeonfish and other herbivores contribute to this living maintenance as well. Their constant grazing helps prevent algae from overtaking coral surfaces. The reef depends not only on what grows, but on what keeps growth in balance. Such relationships often sustain ecosystems through ordinary repeated acts rather than dramatic events. Sea urchins too may play important roles. Moving slowly across reef rock, they graze algae in ways that can support coral recovery. Even small spined creatures can influence the fate of reef communities. Again, the reef reminds us that scale can deceive. Small actors may carry large consequences. There are other reef architects working in different ways. Sponges filter immense amounts of water while occupying spaces among corals. Burrowing organisms slowly break down old coral reef forms, recycling reef material into sediment. This may sound destructive, yet breakdown is part of reef renewal. Even erosion belongs within the larger rhythm of reef building. Coral itself grows in forms that shape whole communities. Branching corals create dense shelter for small fish. Massive corals form long-lasting foundations. Plate corals catch sunlight in layered reef forms. Each form shapes currents, habitat, and the creatures able to live there. Architecture and ecology remain inseparable. Predators also shape reefs profoundly. Reef sharks moving along outer slopes help maintain ecological balance in subtle ways. Predators influence where fish gather, how they feed, and how energy moves through reef communities. Their importance lies not simply in hunting, but in shaping relationships throughout the system. Moray eels hunt from reef crevices. Groupers move through coral reef forms as powerful predators. Octopuses use intelligence and camouflage among reef shadows. Predation belongs not outside reef harmony, but within it. Balance often includes tension. Some forces test reefs more directly. Crown-of-thorns starfish feed on coral tissue, and in large outbreaks can alter vast reef areas. Yet even this belongs to reef ecology. Reefs have always existed amid pressures. Their persistence lies partly in responding to such challenges. There is something fascinating in how much reef vitality depends upon processes that might at first seem disruptive. Grazing scrapes surfaces, predation removes prey, burrowers wear into limestone, storms may break coral. Yet through all this, the reef remains dynamic rather than diminished. Change is part of continuity. Storms themselves have long shaped coral systems. Powerful waves may break branching coral and rearrange reef forms, yet broken fragments can sometimes reattach and grow into new colonies. Disturbance may become beginning. This pattern repeats through reef life with quiet consistency. At night, while larger animals move through darkness, coral polyps extend feeding tentacles and continue their slow construction. Grain by grain, limestone grows. The reef remains under construction, even while appearing ancient and complete. There is calm in that thought, a world continually building itself. Cleaner shrimp and cleaner wrasser contribute in subtler ways. At reef cleaning stations, fish pause, while parasites are removed. These interactions support the health of reef communities. Even maintenance has its hidden architects. And everywhere the reef reveals the same truth in different forms. Builders, grazers, predators, recyclers, and storms all participate in shaping living reef form. No single force makes a reef. It is created through their interactions. Fish move through coral towers, sharks patrol reef edges, parrotfish turn coral rock into sand. Tiny polyps continue raising limestone walls beneath moving tides. The reef grows, is grazed, is tested, recovers, and grows again. Quiet builders may shape worlds, but they do so among many other forces that help keep those worlds alive. Storms have shaped coral reefs for as long as reefs have existed. Tropical seas that nurture coral growth can also produce immense forces of wind and wave, capable of altering reef landscapes in hours. Yet storms are not only agents of damage, they are part of the long history through which reefs have been shaped, broken, renewed, and sometimes strengthened. To understand coral resilience, it helps to understand how reefs live with disturbance. When powerful storms pass over shallow reef systems, waves can break branching corals, shift rubble, and reshape reef surfaces. At first, this may appear only destructive. Coral fragments may scatter across the seafloor. Sections of reef may look torn or reduced. Yet within reefs, disturbance and recovery are often intertwined. What seems broken may become beginning. Broken coral fragments can sometimes settle into stable places, attach, and continue growing as new colonies. A storm may scatter pieces that become future reef form. Open spaces created by disturbance may offer places where coral larvae later settle. Damage can create opportunity for renewal. This does not make storms gentle, but it reveals that reefs often respond through regrowth. There is something quietly reassuring in this pattern. Reefs do not depend upon perfect calm. They have evolved amid periodic upheaval. Their persistence includes recovery from disruption. Different coral forms respond to storms differently. Branching corals may be more easily broken by wave force, yet some can regrow rapidly. Massive corals, shaped like living boulders, often better withstand strong water movement. Diversity of form can itself contribute to resilience. One species may endure impact, another may recolonize disturbed areas quickly. Once again, diversity becomes strength. Storms can also move sediments, alter channels, and reshape reef crests. These physical changes may influence currents and habitat patterns for years. Reefs are not untouched by such forces. They are continually molded by them. And yet storms may also clear accumulated debris or shift conditions in ways that sometimes benefit reef communities. Nature rarely acts through simple categories of harm or benefit. Effects often unfold through complexity. There are reefs that bear visible marks of storms from years past, broken coral fields gradually recolonized by living growth. Such places can reveal recovery, not as theory, but as process. Coral extending again over old rubble. Fish returning to new shelter. Life rebuilding through patience. Recovery often depends on many relationships working together. Grazing fish keeping algae from overtaking damaged surfaces. Healthy nearby reefs providing larvae through currents. Water quality supporting coral settlement. Resilience is rarely the work of one factor. It emerges through connected conditions. There is calm perspective in recognizing how often reefs recover gradually rather than dramatically. Human attention tends to notice sudden destruction. Reef renewal often works quietly through years. New coral recruits settle, colonies enlarge, reef form returns little by little. Patience defines recovery as much as it defines reef growth itself. Storm disturbance can also increase habitat diversity in some cases. Broken coral reef forms and shifted rubble may create new shelter for certain species. Even altered reef landscapes may support life in changing ways. Again, the reef reveals that change need not always mean simple loss. There is another force reefs have long lived with, not storms above the sea, but changes in sea level across ages. During lower seas in glacial periods, some reefs stood exposed. As waters rose, coral growth expanded again across flooded shelves. Reefs have repeatedly responded to changing marine worlds. Storm recovery belongs within that broader history of persistence through change. Some reefs can even grow upward over long periods in ways that help keep pace with gradual sea level rise. This capacity does not make reefs invulnerable, but it reveals remarkable adaptability built into coral life. And there are quieter recoveries too, after localized breakage from fallen coral heads or shifting rubble, after predation events, after bleaching where corals survive and regain their algae partners. Recovery takes many forms. There is something deeply steadying in the image of coral regrowth. A fragment broken loose in storm surge finding stable ground. Polyps extending again. Limestone slowly accumulating. A damaged place becoming living reef form once more. Fish communities often participate in this renewal. Herbivores maintain balance. Predators return as food webs recover. Small reef fish recolonize branching shelter as coral grows back. Recovery is not coral alone, it is community returning. Storms may also remind us reefs are not fragile ornaments, but working systems shaped through force as well as beauty. Their elegance can hide great durability. And still reefs do not recover instantly. This matters. Recovery often follows the reef's own tempo, slow, layered, patient. There is wisdom in respecting that tempo. Some of the healthiest reefs may owe part of their long resilience to surviving and recovering from many disturbances across centuries. Resilience is often practiced, not theoretical. There is a quiet pattern running through all this: growth, disturbance, renewal. Growth, disturbance, renewal. It echoes through reef history. And while storms have long shaped coral systems through natural force, another powerful shaping presence has long been human relationship with reefs. Coastal peoples living beside coral seas, drawing food, protection, and meaning from them, form another part of reef story. Beyond storms and recovery lie those human connections woven through reefs across generations. For thousands of years, people have lived beside coral reefs, drawing sustenance, protection, and knowledge from these living marine worlds. Reefs may seem at first to belong mainly to fish, coral, and sea currents, yet human life has long been woven into their presence. Along tropical coasts and island chains, reefs have shaped food systems, settlement patterns, navigation, and cultural memory. Their relationship with people is not recent. It is ancient and ongoing. One of the most direct connections is food. Reef fisheries have supported coastal communities across generations. Countless fish species spend crucial parts of life among coral habitats, feeding, sheltering, and reproducing there. For many communities, reefs are not abstract ecosystems, but part of daily sustenance. The abundance supported by coral architecture moves outward into human life through fishing traditions shaped by long familiarity with reef rhythms. There is something remarkable in that continuity. Tiny coral polyps building limestone reef forms over centuries help sustain fish communities, which in turn help sustain human communities. The chain of dependence stretches from tiny algae within coral tissues to villages beside tropical shores. Few relationships in nature feel so expansive. Reefs also help protect people in quieter but profound ways. Coral reef forms absorb wave energy before it reaches land, reducing erosion and helping soften storm impacts along many coastlines. This protective role can be easy to overlook because it often works by preventing damage rather than drawing attention to itself. Yet across tropical regions, reefs function as living breakwaters. Once again, tiny builders shape outcomes far larger than themselves. Human relationships with reefs have often involved detailed ecological knowledge passed through generations. Knowledge of tides, reef passages, fish behavior, seasonal changes, spawning periods, and currents may be woven into local tradition. Such understanding often arises not from formal science alone, but from long attention to place. Reefs have been studied by people living beside them for far longer than modern marine biology has existed. There is beauty in that meeting of lived knowledge and ecological reality. Human cultures learning the rhythms of reefs because life beside them required such attention. Reefs also support livelihoods beyond fishing. In many regions, tourism centered around reefs supports local economies through guiding, boating, conservation work, and hospitality. People travel across the world to witness coral ecosystems because few places offer such concentrated beauty and life. Entire communities may depend partly on healthy reefs in ways extending well beyond the water. And reefs have contributed to human knowledge in still other ways. Marine organisms associated with reef ecosystems have yielded compounds studied in medicine. Coral systems have shaped research into symbiosis, resilience, biodiversity, and climate history. Their value extends into science in ways still unfolding. Yet human relationships with reefs have never been one-directional. People depend on reefs, but reefs are also influenced by human choices. This has made stewardship an increasingly important part of reef story. Across many regions, efforts to protect reefs take many forms. Marine protected areas seek to support fish populations and coral health. Local communities manage fisheries with long-term sustainability in mind. Scientists monitor reef change, and restoration projects attempt to support damaged areas. There is no single model. There are many forms of care. Coral restoration can involve growing fragments in underwater nurseries and attaching them to degraded reefs. This work requires patience, much like the reefs themselves. Fragments are tended, monitored, and gradually become part of living reef form. There is something quietly fitting in restoration, working through patience rather than haste. There are also broader conservation efforts aimed at protecting connected habitats like mangroves and seagrasses that support reef health. Once again, the lesson returns that reefs are never isolated systems. There is hope in seeing how many people now work to understand and protect reefs. Scientists, fishers, coastal communities, divers, restoration workers, and conservation groups all become part of this living relationship. Care itself becomes part of reef ecology. And yet reefs remain among the most threatened ecosystems on Earth. This truth has sharpened recognition of their importance. What is precious often becomes clearer when its vulnerability is understood. Still, reefs themselves continue offering signs of resilience. Damaged areas may recover, coral can regrow, fish communities can return, protected reefs may rebound in remarkable ways. The story is not only pressure but persistence. There is calm in imagining a reef recovering through years, new coral recruits settling on old substrate, branching colonies extending outward, fish returning to shelter among growing coral, life recolonizing broken places. Recovery can seem like reef memory made visible. Human relationships with reefs increasingly include learning from such resilience. Diversity supporting stability, slow growth building strength, cooperation sustaining abundance. Reefs offer lessons as well as resources, and they continue doing what they have long done, feeding polyps extending at night, fish grazing reef surfaces by day, currents carrying larvae between reefs, coral skeletons rising grain by grain beneath clear seas. Human presence now belongs among these relationships, not outside them. There is quiet perspective in realizing that reefs and people have long shaped one another. Coastlines protected by reefs allowed settlements. Human knowledge evolved with reef environments. Modern science has been transformed by studying coral systems. Conservation now joins that long relationship. And beyond human connection lies a wider significance still. Coral reefs matter not only to the places where they grow, but as one of Earth's great living treasures, studied around the world for what they reveal about biodiversity, resilience, and the sea itself. Coral reefs are often described as treasures of the tropical seas, yet their significance reaches far beyond the places where they grow. They are among the most important ecosystems on Earth, not only because of their beauty or biodiversity, but because they reveal how living systems create abundance through connection. Covering less than 1% of the ocean floor, they support roughly a quarter of marine life. That alone gives them global importance. Few ecosystems hold so much life in so little space. They are also among the best preserved living examples of how natural systems can record both history and change. Coral skeletons preserve climate records. Reef formations reveal rising seas and ancient coastlines. Living reefs show resilience, recovery, and ecological balance in action. They are studied by marine biologists, geologists, climate scientists, and ecologists because they illuminate many fields at once. Few places join so many forms of knowledge. Their global importance lies too in what they teach about natural disasters and environmental change. Reefs absorb storm energy, help protect shorelines, and reveal how ecosystems respond to disturbance. They show how diversity can support resilience and how slow growth can build enduring reef form. In this way, reefs are not only habitats, but models of living complexity. They attract global interest because they combine wonder and scientific importance. Divers, researchers, coastal communities, and people far from the sea are drawn to reefs because they seem almost impossible in their richness. Coral cities built by tiny animals, underwater worlds glowing with color, ancient living architecture visible from space. These things stir imagination as much as study. And there is something enduring in their importance as historical and living places at once. Some reefs have grown for thousands of years, some deep-sea corals far longer. They connect present life to ancient oceans. They are not only ecosystems of the moment, but inheritances from deep time still alive. That is why coral reefs remain symbols as well as realities. They suggest what life can build through patience, cooperation, and diversity. Tiny polyps building stone, tiny algae helping raise great reef systems, countless species sharing one living reef form, hidden processes sustaining visible beauty. Reefs carry these lessons quietly, and still they remain real places. Fish moving through coral branches, parrotfish grazing reef surfaces, sea turtles crossing lagoons, coral polyps feeding in moonlit currents. The living reef continues its ordinary wonders whether watched or unseen. There is calm in imagining warm, clear water moving over coral gardens, while slow growth continues as it has for ages. Limestone rising grain by grain, larvae drifting in currents toward future reefs, fish sheltering in coral towers, reefs persisting through the patient rhythm that has always defined them. Thank you for listening to the Sleepy Mind channel. I hope you enjoyed learning about coral reefs.